Welcome back, all the participants after the bio break. Now, this is the time to start the second session of the second day of 5 days ACT sponsored ATAL online faculty development program on lean manufacturing in Industry 4.0 scenario. Now, welcome Dr. Raju BS, Special Officer, Professor from School of Mechanical Engineering, Reva University. I would like to introduce the Raju BS, the speaker of the session 2 of the second day. Dr. Raju BS has obtained his PE degree in Industrial Engineering and Management from Bangalore University, Master degree in Computer Integrated Manufacturing from Visvesvaraya Technology University, Belagavi. He pursued his doctoral degree in the area of rapid prototyping, process optimization from UTU, Belagavi. Working as a professor, School of Mechanical Engineering, and a special officer at Reva University. He has teaching experience over 21 years and published more than 50 papers in national and international journals and 40 papers in international conferences. He has 5 patents, 4 Indian patents published, and 1 Australian patent granted in the field of mechanical multidisciplinary. He has handled subjects such as operational research, CAD/CAM, SIM, operation management, finance management and engineering, drawing, computer engine drawing. His areas of interest are rapid prototyping, scheduling and optimization, quality, manufacturing aspects, process optimization, and materials. Dr. Raju BS has been awarded as overall Best Teacher Award 2016 for the entire Reva University, with a cash prize and a laboratory. He has also been awarded as Outstanding Faculty from the Center of Advanced Research and Design, VIF, Chennai, for the contribution achievements in the field of rapid prototyping. He has been awarded as a Best Teacher Award in 2018 and Research Excellence Award in 2018 from the Institute of Exploring Advances in Engineering. He has reviewer and committee member for many journals, international conference, also editorial member for the International Journal, 3D Printing and Additive Manufacturing, Rapid Prototyping Journal, and various open access journals of publication. He has executed several research projects under GTRE, VTU, VGST, Institute of Engineers worth of 75 lakhs. He is a life member of Institute of Engineers, MI, Indian Society of Technical Education, Operations Research Society of India, Rapid Prototyping Society of India, Indian Institute of Production Engineering. Welcome you, sir.
Yeah, thank you, Professor. Thank you for your introductory. Okay.
Yeah, welcome, sir. Thank you.
I'm audible?
Yeah, you're audible, sir. Over to you, sir.
Yeah, okay, thank you. Okay, good morning, one and all the participants. So myself, Dr. Raju, I'll be going to speak about the smart manufacturing and industry 4.0. Just I'll be going to give the glimpse of our bird's eye view of this smart manufacturing, where in the present digital era, which is going to be full of innovation. Okay, so let me see what is a smart manufacturing. Today, it's going to be a customer-driven market, okay, where the customer wants everything at the faster rate with then different design aspects, whatever it may be. So in order to fulfill the customer requirement, the smart manufacturing plays a very important role. So in general, if you want to speak, the smart manufacturing is a technology-driven approach that utilizes interconnected machinery to monitor the overall production process. Okay, so let me see what is this. In brief, let me see in future in further slides. So basically, when we speak about the manufacturing, selection of the manufacturing system plays a very important role. Okay, so what are the key factors that we are going to see while fabricating any product or a component in the present scenario? So there are variety of factors that we take into consideration. So the very first thing is the capacity of the plant. So what is the maximum output that I can produce in a plant, where it will be going to determine the size of the components that size of the quantity that I am going to produce. Okay, that will be taken into consideration. Then second one is flexibility. So as we know, so there's a changeover which occurs drastically, and also within fraction of time the customer wants changes that should be incorporated in the manufacturing system. So the flexibility, then the lead time with respect to both the manufacturing as well as with respect to the ordering lead time. Okay, so that also will be taken into consideration whenever we are going to have. When I speak about the manufacturing lead time, MLT, so what is the time taken to complete that processing of that product, that should be reduced as much as possible, so that we can deliver the product to the customer at the faster rate. And other one is ordering lead time. So as on we are going to have the order, when we are going to deliver that order to the customer, so both should be taken into consideration. This is also one of the important factor that we are going to have. So in the present scenario, whatever we are going to have the production system in push and pull, the pull system plays a very important role. As on when we get the order, we are going to process in the present scenario. But earlier, though we have a demand or not, we used to produce the goods, and it will be stored in the stock. So where the storage cost also will be going to incorporate with respect to the processing of the component. So today in the pull type of production system, we are going to reduce this ordering lead time. Okay, completely it will be going to be zero. Today, if I want to purchase an bullet, as on when if I move into the showroom, it is not possible to procure. If I have a ready model, then I can procure that. Otherwise, I will be going to give a lead time that when the vehicle will be going to be delivered to the customer. Okay, then what is the efficiency of the plant that I'm going to have? Okay, then the environment, then the effect of volume. So these are the various factors. There are n number of factors which will be taken into consideration. These factors are commonly considered whenever we are going to have the selection of the manufacturing system. Okay, so today the future of 3D printing is bright and is increasingly important pillar in the manufacturing renaissance. So, in the present scenario, we have been heard about the additive manufacturing, where we are going to build the parts, all those things. So, there is a drastic growth where this 3D printing will be going to enact as a smart manufacturing when we speak about the processing of the components or prototypes or products, whatever it may be. Okay. So let me see the history of this industrial revolution, what it is going to be. When you speak about the history of industrial revolution, around 18th century, where we used to go for an mechanical production powered by water and steam. Okay, initially the production activity which has been powered by water and steam earlier days. Then in the 20th century, we went on with Industry 2.0, the mass production based on the division of labor and powered by electrical energy, where the machines, all those things are going to be powered by the external resources that what we are going to have. Then in late 70s, the Industry 3.0, the electronics and IT for a further automation of production was been introduced in Industry 3.0. In order to overcome with this, in the present scenario today, the Industry 4.0, where we are going to have cyber physical production system. So the present era is going to be completely digital in nature. It is going to be a digital era with full of innovation. So with full of innovation. So today, this cyber physical production system plays a very important role in order to meet the present customer requirement, demand, and also with respect to the enabled features in the particular product. Okay, so if I speak about this smart manufacturing, you can see the diagram indicates from 19 beyond 2010 what all the things that we are going to have. So the
Sir, the
basically
presentation should be shared, sir. Means only the opening slide is visible.
opening slide,
Showing
no?
your photo.
It is
Please
there?
start. Please move from the other side. No.
Sir, you can press
Click on the
F5.
slide which you want to show.
Fi is there.
Okay.
Yeah. It is visible now.
It is in the first slide only at present.
It is in the first slide only.
Yes, yes, yes. Your photo and the title.
No, check, sir. From my side, it is moving.
But participants, anybody can reply, please.
Now it is moving.
No, sir, it is not at all
First slide
moving.
only visible, sir.
First slide
Not
only,
moving.
because smart manufacturing industry 4.
Sir, please change the
Please share it.
text or move. I mean, you can
Please
press
share
F5, then
Now it's there.
No, sir,
One
it's
minute,
not
sir.
reflected, sir.
Otherwise, it is not moving, sir.
It's not moving. 1 minute, sir. I'll check. I'll check.
Top
You go,
screen
please
sharing.
go to the share screen.
And then
I have
again
gone
share
for
it.
shared screen only.
Okay, now it is
Now it's visible, sir. Smart industry.
slide number
1 minute.
slide number 10.
10,
Yeah.
10, sir.
Okay, sir. 1 minute, sir. I'll share now. Now it's visible, sir.
So slide number 10 is
10 is
visible.
visible, sir.
Okay, sir. Fine. No problem. 2 minutes, sir. Now it's moving, sir.
No.
Now?
No, sir.
No.
Hello, sir.
PPT only visible,
Hello?
sir.
Please
What,
share
sir?
it.
Sir, Smart manufacturing industry 4.0.
Yeah, it's
Okay. When
visible.
I press
Now it's moving, sir.
when I press F5, it is not visible. Okay, I'll do in the same way. No problem, sir. Okay, I'll do it in the same way. It is not a big issue. Okay. So today, when we speak about, now it's visible, sir.
Yes, visible, sir.
Yes, sir. Okay, sir. Thank you. So from the late 90s, if you see, in the earlier days, we used to go for traditional manufacturing, where when we go with respect to the traditional manufacturing, this where we used to have the processing of the components, which is going to be with completely manual, and also in order to enhance the production rate, we used to have the assembly line, then all those things. But later, when we went on with respect to lean manufacturing, where the reduction of the waste, then time, also with respect to the producing of the defective parts were been emphasized, and with a continuous improvement of the processing, the manufacturing activities is to taken into consideration. And in late 1980s, this FMS was been taken into consideration, flexible manufacturing system. So where all the machines, the complete manufacturing unit will be going to be integrated, and we will be going to produce the components whatever we are going to have. So the reliability of the system will be going to be enhanced, and also with increased with the variety of the parts that can be produced in the flexible manufacturing system. So as on the customer changes the design or whatever it may be, within fraction of time we can go for fabrication of that component by using this FMS. Okay, so there is a massive response to the engineering changes that we are going to have. Okay, then in 1990s further it went on with respect to a reconfigurable manufacturing system, where this reconfigurable manufacturing system has been for the rapid change in the structure, whereas we will be going to have with respect to both hardware and software components in order to quickly adjust the production system that we are going to have with the proper functionality within a part family in the response of the market changes. So here basically when we speak about this reconfigurable manufacturing system, here the use of mechanical with respect to the processing of the components, controlling, then hydraulics or pneumatic module, and also the electrical modules that can be rapid adaptability can be achieved in this reconfigurable manufacturing system. So the main goal of this reconfigurable manufacturing machine tool is to handle various changes. What all the changes that we are going to have in a product or the parts to be machined that can be taken into consideration, where we go with respect to reuse, reduce, and recycle of the things that we are going to have. And but presently today, whatever we are going to speak, we have with respect to sustainable manufacturing, which is nothing but cloud-based manufacturing system, where the creation of the manufacturing products through economically sound process that minimizes the negative environment impact while conserving energy and natural resources. So even this sustainable manufacturing can be related to green manufacturing, where it is a method of manufacturing that minimizes the waste and reduces the resources impact. Whatever the resources, environmental resources impact, that will be going to be reduced in the sustainable manufacturing. So basically, when we speak about what all the key factors that are required for us, the key factors are going to be like eliminating the waste, then remanufacturing, reduce or eliminate the pollution, redesign, recycle, recovery. All these are going to be the key factors that are been required for achieving the sustainable manufacturing. Okay, so here we'll be going to have an manufacturing resources where it will be going to reduce the cost, reduce time to market, and also improve the resources reuse that we are going to have. By all these things, we will be going to have improved machine utilization. So the next slide, it shows, it clearly indicates the criteria that is going to be required for us with respect to the smart manufacturing. So when in the earlier, when we used to go for mass production, where we have to have interchangeable parts, which is going to be mainly based on the cost that we are going to have. And further in 1960s, the quality was been emphasized. Then further later on, the variety of products that we want to produce with mass customization, and finally with scientific knowledge and reconfigurable manufacturing with more responsiveness, the components or parts are been going to be produced. So the smart manufacturing is a technology driven approach that utilizes internet connected machinery to monitor that production process. Okay, so when we speak about this criteria, so the reuse, recycle, redesign, reduce, eliminate waste, all these are going to be the key factors for achieving this sustainable manufacturing. Even the materials also plays a very important role when we go with respect to the sustainability. So these are the criteria that we have with respect to the manufacturing aspects that in the present scenario. So what is this smart manufacturing, and what is the impact on the supply chain that we are going to have? So as I told, in the present industrial revolution, it is a digital era with full of innovation, all those things. The impact on supply chain is nothing but with respect to the globalization, then a decreasing cost, higher efficiency of the operations, then quality improvement, then improved services. All those things are going to be the impacts of this smart manufacturing when we speak about the supply chain. So overall, all the parts, whatever we are going to produce in the manufacturing with the smart manufacturing are going to be logistic impacted. It is going to be logistic impacted. So in general, in order to define this smart manufacturing system that are fully integrated, which are going to be collaborative manufacturing system that respond in a real time, which respond in a real time to meet the changing demands and condition in the factory within the supply network and customer needs. So today, as I told, even today it is a customer driven market. customers are very important. So all these factors will be taken into consideration in your smart manufacturing. So as a service, when we take the cloud-based manufacturing with high level of customization has been enabled by this smart manufacturing. For an example, I have given in house and the devices that we are going to use in the houses. So here you can see the IoT will connect our smart homes and smart devices. Okay, the Internet of Things plays a very important role in our day-to-day life, where it will be going to connect the smart home and the smart devices. So all the things what we are going to have. Okay, so with respect to the home automation, we are going to interconnect with respect to the smart home and the smart devices that we are going to have. Okay, so by using the available resources, okay, so we are going to interconnect each and everything in the smart manufacturing. So what is this IoT? So the IoT paving the way to the industrial IoT. Okay, so earlier they used to integrate. It is the industrial IoT is nothing but it is a part of a larger concept which is known as an Internet of Things. So the IoT is a network of intelligent computers, a device, and objects that collect and share the huge amount of data that we are going to have. So by using a central cloud-based service, we are going to share the information, and the IoT will increase the automation with respect in the various industries depending upon the type of the products that they are going to produce. Okay, so the this smart manufacturing has been replaced the traditional industrial platforms, whatever we are going to have like software or even our PLC controller, the technologies that break free of device or operating system or protocol dependency, all those things have been replaced with respect to this industry 4.0 with IoT things. Now this industrial IoT will connect smart machine in the smart factory. Okay, so we can see globally the facility whatever we are going to have, we can interconnect one another, and we can go for manufacturing of the components. So wherever we have the manufacturing plant, we can share the information through the cloud, and we can go for manufacturing. Almost at the end of the session, I'll be going to illustrate with respect to e-manufacturing, how we are going to build the components. Staying in Bangalore, we can build the components in Mumbai, or we can build the components in Delhi. I will share that slide also with respect to e-manufacturing. Okay, so here, when we speak about this, more intelligent, autonomous, and connected machines have been taken into consideration, where it triggers autonomous material handling vehicles, and also it manages the equipments remotely using the sensors and limits to conserve energy and reduce the cost. Okay, so when we speak about this smart factory, overall integrity of the system plays a very important role. So the implementation of condition-based maintenance alerts to reduce the downtime and increase throughout with respect to the processing of the component, and also monitoring the production flow in real time to eliminate the wasted time and reduce in process inventory. All those things will be taken into consideration in a smart terms. Now, when we speak about the IoT, smart manufacturing, IoT and digital manufacturing are enablers for smart manufacturing. Digital manufacturing and IoT, Internet of Things or Industrial Internet of Things, these two are enablers for smart manufacturing. What is this smart manufacturing industry 4.0? if you see over here, I have given the smart industry where it digital factory, sustainable factory, smart working and skills, okay, and smart manufacturing and also flexible manufacturing. Here, the smart industry is pushing digitization beyond the information that we are going to have. The flow by focusing on the digitization of physical assets and system by creating a digital identity for them. So basically, when we have this thing, generating, analyzing, and communicating the data seamlessly underpins the potential benefits that are going to be promised by Industry 4.0. So when we speak about this new technologies, the new technology such as artificial intelligence, robotics, IoT, then autonomous vehicle, 3D printing, nanotechnology, biotechnology, material science, energy storage, all those things are going to be the industry roadmap that will be going to enable us for a smart factory or smart industry. Even quantum computing will fundamentally help us in order to see how to work and how we relate to one another. All those things will be taken into consideration. Okay. So the smart industry will enable on demand production. It is going to be enabled on demand production with respect to mass customization. Okay, where it enables productivity, employability, skill, working environment, then income distribution, trading, and also with respect to the environmental resources aspects, whatever we are going to have. Okay, so as I told, the digital manufacturing and IoT are the enablers that we have for this smart manufacturing. Okay, so now let me see how to these are the technologies, new technologies that we are going to have with respect to industries 4.0, Internet of Things, smart sensor, advanced robotics, the big data analytics, 3D printing means additive manufacturing, augmented reality, cloud computing, location detection, artificial intelligence. All these are going to be the new roadmap for the smart industries, which enables with respect to the production activity. Now, let me see with respect to the aspects of these things. So when we speak about this production, these three things plays a very important role. What are those key parameters? The IT technologies in smart manufacturing is going to be the Internet of Things, cloud computing, and advanced data analytics. These three plays a very important role in the smart manufacturing. What is this Internet of Things? Where the description indicates that where we are going to communicate between all the IoT devices. So as I told, in the smart factory, you are going to have interconnectivity of all the machines, then all the metal handling devices, what all the systems that we are going to have, which will be going to be interrelated to each other. So when we speak about the Internet of Things, it will be going to have a communication between all the IoT devices from M to M communication, machine to machine communication will be going to have, and where this communication will be taken care by using sensor and RFID data, which these two will be going to gather the information and will be going to enable with respect to this smart manufacturing. So the example I have taken oil and gas industry, the oil extraction temperature, the rates and well pressure monitoring saves a company around $1,45,000 per month in a repair saves. Okay, so recently in Dubai, the oil and gas industry, they have been using these concepts, and they have been enabled to save a lot of the investment. So what are the benefits that we